Welcome everyone to today's food safety webinar, part 2 of agricultural water. In this second of a two-part series on agricultural water, we will identify risks that impact food safety related to water sources, practices that can reduce those risks, FDA water quality criteria and the importance of water testing, necessary records to document agricultural water quality, required quality of water for harvest and post-harvest activities, cross-contamination, and the practices to maintain and monitor the quality of water used in post-harvest activities. We will also discuss the latest actions by FDA related to agricultural water standards. This webinar is part of a series of food safety webinars coordinated and conducted by the Indigenous Food and Agriculture Initiative to help Native American farmers, ranchers, and food producers understand the importance of food safety and what is necessary to reach compliance under the Food Safety Modernization Act. Attendees will learn about produce safety, foodborne pathogens, worker health, wildlife, land use, post-harvest handling, and legal issues associated with food safety in Indian country. The IFAI has also launched a series of in-person food safety trainings in regional locations. I encourage you to visit our website at indigenousfoodandag.com/foodsafety for a listing of these trainings and information about how to register. The in-person training events will result in the award of a certificate. The webinars we are hosting will help you better understand these issues and will help prepare you to participate more deeply in the regional training events. We will not award a certificate for the webinar trainings. We're merely trying to broaden knowledge of the important principles that will be covered in the regional training events. If you look at the handout section of your control panel, you'll find the slideshow being presented today and other agricultural water resources referenced in today's presentation. I invite you to visit our website at indigenousfoodandag.com/foodsafety, where you will find links to these resources, more information about our food safety trainings, downloadable copies of the presentations, and archived videos of the completed webinars. The issues we will cover in business practices, microbiology, and legal issues are additional information our experts think is important to have access to as a grower. All attendees will be muted during the presentation. Today's presenter, Dr. H.L. Goodwin, will take questions at the end of the presentation. Attendees can submit a question by using the questions feature of the control panel. We will also be conducting a live poll during this presentation. When we reach the live polling slides, I will provide instructions for using your mobile device to participate in the poll, and poll results will appear in real time on the slide. We encourage everyone to participate in this poll, so please keep your mobile device handy. Today's presentation is possible through a 3-year cooperative agreement between the U.S. Food and Drug Administration and the IFAI to provide Native American outreach, training, technical assistance, and education to ensure compliance with the Food Safety Modernization Act. Our work is part of the broad efforts we will undertake to provide outreach, training, technical assistance, and education on food safety issues. I'd like to introduce today's presenter, Dr. H.L. Goodwin, the Senior Economist and Food Safety Director at the Indigenous Food and Agriculture Initiative. Dr. Goodwin is a professor and poultry economist at the University of Arkansas in Fayetteville, a Senior Economist and Food Safety Director at the Indigenous Food and Agriculture Initiative, and the Director of Student Networking and Curriculum Enhancement for Bumpers College. He joined the faculty of the University of Arkansas's Center of Excellence for Poultry Science and Agricultural Economics and Agribusiness in December 1997. Prior to joining the university, he was the Agricultural and Food Systems Policy Advisor to the Minister of Agriculture in Slovakia and a Fulbright Scholar in Czechoslovakia. He was faculty at Texas A&M's Department of Agricultural Economics and served as the Associate Director of the Texas Agriculture Market Research Center. He received his PhD in Agricultural Economics from Oklahoma State University in 1982. And with that, HL, the presentation is yours. Okay.
Okay, go.
Yeah, I can certainly do that. So
Nothing's going on here. So that's the slide we had up originally. But now we've got the ag water quality part on here,
okay.
rather than the post-harvest part. While we're getting this worked out, here we go. Look at that. Module 5, Part 2. So what are the learning objectives of this module? They're shown here on the slide. But essentially what we want to do is figure out what we need to do with all of our water that we use post-harvest. Very important to maintain and actually to advance the quality of the water you use post-harvest. You should actually start with potable water. We need to be aware of ways water can be contaminated and how to avoid cross-contamination and infiltration, which is something that many of us don't think about. We'll explain that. We need to talk about antimicrobial products, including sanitizers. We'll be looking at practices to maintain and monitor water quality, record keeping that's necessary, and corrective actions to use if your post-harvest water, which you must test periodically, gets outside your microbial criteria. So what do we want to focus on post-harvest water? You know, you can't eliminate everything in the field. Bottom line, no matter how carefully you monitor your agricultural water, there is the potential of contamination and food safety problems that happen during harvest and during hauling to the packing shed and the place where you rinse and prepare your vegetables and your fruits. And post-harvest water really spread contamination widely. I want to just mention one particular instance that happened, I think was about 4 or 5 years ago with cantaloupe in Colorado. What happened is, if you notice, think about the surface of cantaloupe. It's very uneven and like almost net-like. What happened in the rinsing tanks is some of the cantaloupe were contaminated. One of them burst. It got into the cantaloupe there, and then it spread because of the rinse water was in a tank. It spread throughout all of the cantaloupes, or many of them, and there was a huge recall. So it can be a big problem. So what do we use post-harvest water for? Rinsing, washing. You know, you use it in your dump tanks and your flumes if you're big enough to have that kind of a operation where you're moving product via water to another area. Cooling, ice making. This is a big one people don't think about a lot. Ice making is a big potential way to get contamination. Fungicide and wax that you may apply on certain fruits. Hand washing, can't forget hand washing. Remember, we had an entire webinar on worker safety, and I would urge everyone to go into our record and our files there of these webinars that we've had and pull up the one on employee training. There's a great amount of work that's been done on how to properly train your employees to prevent contamination. A big part of it is hand washing. And then also, it's almost so obvious we needn't mention it, but cleaning and sanitizing. I do want to mention the difference between cleaning and sanitizing. You cannot sanitize an unclean surface. Let me explain what I mean by that. If you have a surface that has grime or dirt or something like that on it, it has to be removed by physical means before the sanitizer will work on the contact surface. Otherwise, you risk having buildup of a biofilm, and then you simply spread your contamination. So before we can think too much about this, we have to know what quality of water we're starting with and how it interacts with any treatments we might have. For example, if you have water that maybe has some dissolved solids in it, and you add certain kinds of compounds in there for your treatments of your fruits or vegetables, you could have a situation where you get settling. You could even have a problem with creation of gases that would be emitted that wouldn't be good for your workers. Antimicrobial products, including sanitizers. Now, here we say again, a sanitizer to water is not intended to wash the product, but to prevent cross-contamination. Importantly, it must be labeled for the intended use. And I would urge each of you, each state has different products that they have approved for use in that state. Sometimes, many of them are the same across states, but some states have differences. I would urge you to contact your state agricultural department or whoever is in charge of that particular activity, and check with them to see what types of sanitizers are approved for your state. So there's a lot of sanitizers that are available, and a lot of them are even fit in your organic categories if you are an organic producer. So you needn't worry about that. I'm having trouble again, Brian, with my advance. Now, here we go. Let me talk a little bit about, I mentioned starting with potable water. We need to begin all of our activities with potable water, and it needs to be verified through testing. You may think you have potable water, but there could be some leakage in your system. I talked last time about rural water systems or even municipal water systems that have cracks in pipes or some leakage and back infiltration into the system. That will contaminate your water. So it's good to test and verify your water. Brian, I have a question. I'm getting an echo when I do my audio. Do we know what's causing that?
That might be on your end. I'm not hearing an echo.
Okay.
But I know that can be extremely annoying.
Yes. Okay, I'll proceed.
And HL.
So let's.
HL, yes, just so you know, I'm advancing the slides. So when you get to the end of a slide, I'm just going to advance it.
Good. Okay. Thank you. What about cross-contamination? You start with water that is equivalent of drinking water, but then you've got the problem of cross-contamination. How can that occur? Pathogens, may be introduced by other produce or by non-produce material. Could be introduced off of your containers, off of contact surfaces or other sources. So there's a complete standard operating procedure that you should go through. And you see there on your, on your handout section on the screen, sample SOP for agricultural water. And Brian this week will also load up sample SOP for post-harvest water overview. And we'll have the agricultural water decision tree is on there. We'll have the post-harvest water decision tree and also testing logs and verification logs. So all that will be loaded up. But so we have cross-contamination from many sources. And you see here where most of the cross-contamination, in fact, comes in post-harvest is from the worker. Workers' hands, workers' clothing. Workers need to come to work in clean clothing. They need to be properly dressed. They need to have on gloves. They need to be properly washed after toileting or eating. Your produce containers can be contaminated, particularly if you're using bulk containers. Things that could be, for instance, if you have a citrus or an apple operation and you're using apple boxes, those can be contaminated. When they're not in use And many times when they are in use, little vermin like to run around on those. So we need to make sure that we sanitize, clean and sanitize our containers, our packing tables, and then your tools. Many times we don't think about this, but tools must be cleaned and sanitized. So what's a water quality criterion for harvest and post-harvest activities? You can see it there, no detectable E. coli per 100 milliliter sample of water. And we talked 2 weeks ago in the agricultural water webinar that EPA has approved 8 different methods for testing for coliform. Originally, there was only one in the that was approved for that, but now there are 8, and 2 of these are are ones that can be used. It's the Col Alert and coliform tester that you use with strips and coloring, and those are excuse me, those are available, and those Col Alert test kits by IDEXX only use those, and there are specifications on those that you can have, but that allows you to check for your water. That's for any water that has direct, excuse me, Brian, I wasn't quite finished here. Any water that has direct contact with the produce or with food contact surfaces, or to make ice, or for hand washing. I've got a little story that I'll tell on myself. Many years ago when I was in college, I took a course in Mexican art. Now, and so I was curious what that was. We had to take 2 humanities classes. It was a 1-week trip to Mexico to look at the various, the pyramid of the moon and the sun and the various architecture and so on. It was an interesting class, as it turned out. I went because I was getting a week in Mexico, but so we were going across on this tour, and we'd been warned. This is back in the early 70s. We'd been warned about the water, and this friend of mine got a bottle of pop out of a tub that had been iced down, and I said, "You better not drink that." He thought I was a little bit crazy, but he wound up being fairly ill for about 3 days. So ice is a big carrier of cross-contamination and bacterial issues. So anyway, let's keep going now. So what do you have to do if you've got untreated groundwater? It's the same testing requirement as we saw last time, 4 or more times during the growing season over a period of a year. Public water supply, copy of test results or current certificates of compliance are required. But I mentioned if it was me and I was producing and packaging produce, I would want to periodically use one of these Col Alert tests just to make sure that there wasn't a problem after it left the municipal water supply or the rural water supply. You know, they're responsible for the trunk lines, but from there to your spigot is your situation. So I think it's good to really stay on top of that. It's good prevention, and it's cheap insurance. Now we see here single pass water. What in the world is single pass water? This decision tree that we'll have loaded up next week, the first point of decision is, do you have single pass water? That is water that is only used one time and then is taken out and disposed of in some type of disposal system. Water, the produce safety rule doesn't require water treatment if it meets this detectable limit of E. coli. Antimicrobial products can be added, and it's a good practice. It's commonly recommended as a good agricultural practice to have these sanitizers, and that's important in reducing the buildup of microorganisms, these biofilms that I mentioned. I don't know if you've ever thought about biofilms, but if you, probably not, but if you have a pet and you look at the bottom of their water bowl, you can see a lot of times slime that builds up there. The only way to get that off is by scrubbing it with some kind of a brush or rough surface to break that loose. That is a biofilm, and biofilms harbor bacteria. So we don't want biofilms. You got to keep those broken down. And the reason we use antimicrobials and sanitizers is to keep the biofilm from starting in the first place on your food contact system surfaces and your equipment in your system. Now, what about batch water or water that's reused? Pretty much the same on the first two. You have to have that at the beginning of use and maintain an adequate sanitary quality throughout the use. And you do that by having a schedule of when you change your batch water or some process for minimizing buildup of organic material in the water. How frequently do you change it? Does it go through a filtration process to remove that organic matter from the water? And and here it's very important that you only use microbials, antimicrobials that are labeled for fruits and vegetables. One thing that that happens in these bulk tanks, leaves, stems, dirt, harvest containers can get submerged in the water. All kinds of things can happen to contaminate the water and reduce effectiveness of your sanitizers. So, the more of this rubbish and turbidity that builds up in your water, the less effective your sanitizer. So not only do you get contamination, but you get decreased effectiveness of your sanitizers. And turbidity really, particularly if you're using an organic-based sanitizer, can really be a problem. Chlorine-based or something like that, you can get some hazardous gases that are given off. So you need to really develop a system so that you have a schedule for changing your batch water. So what are your water quality variables? We talked about E. coli already. pH, the acidity of the water can affect the antimicrobial treatments. Some are more effective in slightly acidic water, some in neutral water. So you need to check that. Temperature has to be monitored to minimize a potential for infiltration. And we'll talk just briefly about this infiltration. A lot of times we don't think about that, but if you've got vegetables or fruits, and this is particularly true for tomatoes and apples and cantaloupes, these are the three biggies, melons, if they're susceptible to water infiltration, when the pulp temperature of the fruit gets to be warmer than the water into which it's submerged. So if you had normal temperature well water, say it's 66 degrees or something coming out of the ground, or you had municipal water that was at 80 degrees and the core temperature or pulp temperature of your fruit was 100, then what will happen is as soon as that's submerged, it can create a vacuum inside the produce and water will be sucked into the fruit. And if that water is contaminated, then you get contaminated fruit. And that's what happened with the cantaloupes. So if you have if you have a situation where you want to reduce the risk of infiltration, keep batch and bulk water the same temperature or less than 10 degrees warmer than the pulp temperature to avoid deep tanks. So obviously, if you have spray water or something like this, it's better. Also, some people use an initial cooling stage to lower the core temperature of the produce prior to washing. So that's another technique that can be used. Chlorine is one of the most frequently used sanitizers, and it is also one that is very impacted by the pH. And so you need to have, you can get pH strips. They're cheap, little pH meters. You can titrate them, have little test tube kits. You see the one there is a titration kit where they match the color of that stick to a guide there to see what their pH is. When you add chlorine or something else to the water, you can change the pH of the water. So you have to monitor your treatment, and you need to adjust the pH so you get the optimal one for your sanitizer. So there's a lot of interactions here chemically with the pH, and it's something that we need to be aware of. Typically, chlorine lowers the pH of the water, and so that's something we need to be aware of. Here's some more information on temperatures. We looked at, or we've already talked about that prior to looking at this slide. I want you just to kind of look at the little danger sign down there. Temperature can affect the efficacy of antimicrobial products, including sanitizers. If the water's too hot and the pH is too low, chlorine may gas off and become a health hazard. There have been many times you'll see plants, food processing plants, where they use bulk tanks for cooling or sanitation that will have a toxic gas off of chlorine, and they'll have to shut the plant down and take that air out, suck it out, and handle that, and then check to make sure there's nothing hazardous for the worker. So it's something to be aware of. You've got to monitor your pH. Here's a picture of, on the infiltration, of dye going into a cantaloupe. So if dye goes in there, you can bet your bottom dollar bacteria is going to go in there. Your pathogens are entering, and once they get in there, it's nice and moist, and it has a nice pH, and the temperature is conducive for growth, and it can stay in there a long time before it's eaten. All your characteristics of Fat Tom that I talked about. It's got plenty of nutrition. I talked about Fat Tom at the beginning of these webinars in 2 different ones. So just remember, if you use deep submersion or have it in there a longer period of time, you're more susceptible to infiltration. If you've got a bruise or a wound on your fruit, obviously you're going to have infiltration. And then the temperature of your water. When produce is warmer than the tank water, you're going to have infiltration because of this vacuum situation that builds up within the fruit and draws that in. It seems almost too simple to talk about, but when your water gets turbid, it's time to change it. Figure out what your tolerance is for your different conditions, for your sanitizers, for the products that you're using. Monitor these turbidities. You can get a turbidity meter. And if you've got turbid water, you're lowering the effectiveness of your treatment, possibly. So in that case, you need to add more sanitizer to be effective. And so it's a trade-off that you need to figure out. Am I going to change my water more frequently, or am I going to monitor it and add more sanitizer? You know, it's a trade-off that you have to think about. What's the cost of your water? What's the cost of recycling water? What's the cost of adding more sanitizer and adjusting the pH? So all these things are acting together to determine the safety of your post-harvest water. When do you change your water? It depends. We've talked a lot about organic loads, soil, leaves, damaged product, decaying pieces of produce that have broken off for whatever reason, your turbidity, the volume of produce that you're putting through, the type of produce, what type of antimicrobial product you're using, what kind of equipment do you use, what's your product flow and operating conditions. Obviously, if you have nice, smooth fruit that's uniform, and you get better coverage, you're not going to need as much time in the water, as much volume of water, or probably as much volume of sanitizer. So the surface of the produce determines a lot of that. What do we do with our used water? It has to be, you can't just dump it out on your field and let it run out, because that's a source of contamination. You've got to dispose of it properly. If you want to use that water in a field that does not grow covered produce and grows something else, pasture, or let's say something like dried beans, or many of the things that aren't eaten raw, aren't typically eaten raw, then that's an obviously good way to use your so-called gray water. Hand washing stations must have catch basins if they're not connected to a drain. Many of you will be using portable hand washing stations. If you have that, you have to have a basin underneath that to catch the water, and you must have a system to collect these catch basin water and reprocess that, haul it away, and dispose of it properly. Check state, local, and EPA regs on discharging water into sewers or septic fields or surface water. So all that needs to be checked. If you're fortunate enough to be on a sewage system, then just figure out what the cost of that is, figure out what the restrictions are with respect to any of your sanitizers, and go forward. Probably, unless you're using a great volume, it would just show up on your bill and there wouldn't be even a problem with that. But check first. It's always best to find out the legality and the limits of that before getting into a situation where you have to make a repair or a compensation for a violation. So here are the antimicrobial products. Chlorine, we already mentioned, was commonly used. It's affordable. It's available everywhere. It is corrosive and it is highly reactive. So you got to monitor your water quality. If you've got a real turbid water situation building up with a bunch of plant refuse in it, don't dump chlorine in there. You'll get chlorine gas emitted at dangerous levels. Many people use ozone, peroxyacetic acid, hydrogen peroxide. There are all kinds of chemical options that you have separate and apart from chlorine. And many of those are quite reasonable and readily available. There are some organic formulations available. Here are a few of them that are mentioned. But the key thing, no matter what you use, must be labeled for use on produce. Please do not take a bottle of Purex or Clorox that you use in your laundry room, and don't take those and dump them in your wash water as a sanitizer. It must be labeled for food use. Follow the label instructions. They go FDA, EPA, and all the other agencies spend a lot of time making certain that manufacturers of products inform the user how they should be used properly for maximum efficacy and safety. That's the reason those labels are on there. And so use it only as it's labeled for, use the correct amounts, however it's prescribed there in parts per million or pints per gallon, or however it's used, whatever the instructions are, and understand that temperature, pH, sunlight, and organic load are all determine how it's affected by the organic load. So all these things determine the efficacy of your product, and they need to be taken into consideration. And here's an example of a label here. So this particular one, I just hammered Clorox, but this particular one is for fruit and vegetable washing. So if it's on the label, then it's okay. It gives you the exact descriptions here, how to use it as a sanitizer, how to clean the tank, and how long it should be exposed. So the label's there to help us. We have to monitor these antimicrobials and sanitizers. Anytime you use any of these things, you have to monitor them, check with the supplier. They have all different kinds of monitoring tools. One of them is mentioned here, the Oxidation Reduction Potential Sensor. So get these monitoring tools, learn how to use them, and employ them as recommended by the person or the firm manufacturing your sanitizer. And in many states, Cooperative Extension Services put this information out. Maybe the state health department is in charge of that in your particular state. Could be the Department of Agriculture. Check your various resources and find out how you should monitor your antimicrobial and sanitizer levels. Here it talks about the oxidation reduction potential. I'll leave that for you to read if you when you get to that point of needing to look at your sanitizer efficacy. But this essentially gives you the range in which your sanitizer will control cross-contamination with chlorine-based sanitizers. So that's what this is for. They're fairly simple and they're effective in small-scale systems. But don't get a cheap one. There's too much writing on it to pinch pennies. So what are some SOPs for post-harvest management? As we said, we're going to put that in our handout box, and it will be posted by the end of the week. But they're all types of things that we need to do there. Monitor and adding of microbial products. The same with monitoring and modifying pH, water and pulp temperatures. That's a big one. Water and pulp temperatures. I bet most of us have never thought about taking the pulp temperature of our produce when we pick it. We just pick it and rinse it off. So that's something that was really driven home to me when I went through this course initially, is to learn about this infiltration issue. We've talked about the turbidity question, and also something there, calibrating thermometers and sensors. We can't just get equipment and not calibrate it. If it's intended for measurement and monitoring, we need to calibrate it periodically so that we know that it's still working as it was designed and giving us good information. Otherwise, we might not like the result. So when do you need to do corrective action? You need to do corrective action when your monitoring shows that your water sanitation procedures aren't working. Your antimicrobial treatment is not effective. It needs to be increased. You're low on sanitizers. You're using it up faster than you expected. What does this tell you? Well, it tells you maybe you've got a problem with a lot of organic material in your in your rinse tanks. Your pH readings are off. You know, all these things cause a need for corrective actions because you'll get out of compliance on your water quality. When workers report a problem, you need to respond to it. You know, the workers are the ones that really know what's happening out there. And so when they see a problem, it needs to be responded to. And if you have monitoring and record keeping sheets that are incorrect, that means either you're recording the wrong thing or you're measuring it wrongly. And in either case, you've got a problem. So if you've got a problem in your record keeping, it needs to be fixed, because that's the only way. If you're called upon in the event of a foodborne illness that can be traced to your production operation, that's the only way you have of showing that you followed good agricultural practices. So record keeping and monitoring are a must, and if you've got an error there, it must be fixed. Every one of these, I talk about record keeping. Document your water quality test. Anything to do with your antimicrobials, your monitoring, your corrective action, anything to do with water quality, keep a record on it. And that does two things. One, it covers you in case there's a problem, but two, it tells you that you're completing and having effective monitoring practices. Sanitizer levels, pH, turbidity, any change in water, et cetera, et cetera. Your temperatures would also be interesting to do. And I guarantee you these folks that did the cantaloupes, that got everyone's attention. So, you know, cantaloupes like to grow in the heat. If it's 100 degrees out there and you're picking them in the afternoon, it's likely the pulp temperature of the fruit is going to be quite a bit higher than your water temperature. So, you know, all of these things in record keeping is to identify trends and patterns that you need to be aware of so that you can either correct your practices, correct problems, or verify that you are in fact in compliance with your own best practices and the standard operating procedures. So in summary, water management can help prevent a small contamination event from becoming a big one. Use only water that has no detectable E. coli in 100 milliliters of water. Consider using a sanitizer on your post-harvest water. Develop SOPs for key water management steps. Monitor your key variables. Take corrective action when needed and keep records. You know, these are 7 things that if you follow these, you won't have a problem with your post-harvest water management. It'll work just like it's supposed to, and that's the intent of this particular aspect of the FSMA produce safety rule, is to make sure that when you get to the post-harvest stage, contamination is not reintroduced by any of various means. So, Brian, I think that brings us to the end of our presentation for today's webinar. And I would mention, Brian's going to transition you into the survey, but I would mention many people, if you have already completed one of these, please do so in each webinar. Okay, Brian.
All right, thank you, HL. We did have a couple of questions that came in, so I'll get to those right now, and then we'll go into our survey questions. The first question was, you mentioned gloves, but FSMA does not technically require workers to wear gloves. Is that correct?
That's correct. But you have to use hand washing. You have to be able to verify hand washing, and gloves must be clean and in operating condition. They cannot be grimy.
All right, and then we had a second question, and this is in reference to the infiltration that we saw in the cantaloupe example with the dye.
Yes.
In reference to infiltration, how long is too long for a melon to sit in a dunk tank? 1 second, 30 seconds, 3 minutes, 5 minutes? I'm curious if that melon infiltration example that was dyed was from an experiment where they let the melon sit in the water really quickly, or if they let it sit in there for 5 minutes, etc.
Well, I can't speak to that slide, but that does raise some good issues. Remember the factors that determine infiltration: the core temperature of the fruit and the temperature of your water. In addition, the sanitizer you're using, and the depth and volume of the tank. For example, if you have a very deep tank and you're submerging literally thousands of cantaloupes in there, some of them are going to get lower in the water, and the added pressure as you move down the water table will enhance filtration. So follow the rule of not having your water cooler than the core temperature of your produce. Also, look at your sanitizers and make certain that the contact of those sanitizers on the fruit is not excessive. It may say, 2 minutes at this temperature and this pH is adequate. We saw that on the bottle of Clorox. It went into some detail. So if you follow those sanitizer labeling recommendations, and you pay attention to the water temperature differential, it should limit infiltration. I can't really respond to how they got that picture, but it's pretty startling.
So that'll bring us actually to the end of the presentation. Did you have any final thoughts? On the screen that we have up right now, I just want to encourage everyone to be sure to register for our next webinar, which is FSMA Preventive Controls for Animal Food Update. And we have had several technical issues today. I want to apologize to our attendees for that. We will definitely work on getting some of that ironed out in the future. But we do appreciate you attending. I encourage everyone to go to our indigenousfoodandag.com/food safety webpage. You see the web address on the screen there. You'll be able to access a recording of this webinar, the materials that were referenced in this webinar, and also all of the previous webinars that we have done. You'll find videos there. So definitely visit our webpage. What you'll also see on this page on the right column, you'll see a listing of our upcoming webinars, which include the animal food update that we'll be doing on November 21st. Any final thoughts, HL?
No, I would just say this animal food update, for any of you that are in the business of producing food or utilizing food for meat animals, it would be very good for you to attend this, tune into this. This is running a little bit behind of the produce safety rule, but it's being ramped up, and the good manufacturing practices are the basis for feed manufacturers, are the basis for the animal food regulation. So I'd encourage you to at least get an update on that. It's quite extensive, and so this webinar will only be an overview for that, but it gives you an idea of what you need to be prepared for.
All right, thank you, HL. And with that, I'd like to thank everyone for attending, And hopefully we will see you on November 21st for our next produce safety webinar. Thanks for joining us.